Data centers spend anywhere from $30,000 to $100,000 every single month just on energy. And on the surface, that might seem reasonable. I mean, after all, a typical data center might be running 5,000 to 10,000 GPUs around the clock. But here's the thing, all of that energy isn't being used. Every single data center faces what we call invisible problems. Invisible problems are problems that you can't see. Small inefficiencies like a single rack not receiving enough cooling or a pump that's running harder than it needs to will quietly drain your budget without you even realizing. And the bigger your facility gets, the more these invisible costs start to add up. And the problem is, since you can't see them, most facilities have no idea that they even exist. You might be paying $100,000 per month on energy, but $20,000 of that might be contributed to inefficiencies, which if you eliminated would cut your bill by $20,000. Now, I'm sure that we all like money and we would love to have more of it in our pockets, but most facilities, they only monitor total energy use. You can see the big number on your main panel, but you can't see where the waste is coming from. That means a cooling unit that's drawing extra power or an overloaded circuit goes completely unnoticed. And this is why monitoring is so important and why we always talk about it on this channel. Almost all of your issues in your data center can be attributed to not having adequate monitoring. So if you want to get serious about cutting waste, you need to follow what I like to call the golden standard in monitoring. For one, you need to be able to catch the environmental issues, things like temperature, humidity, and airflow at the rack level. For two, you need circuit level visibility, so you know exactly how much energy your chillers, pumps, and fans are consuming. And lastly, you need something that takes that data in real time and acts on it automatically, adjusting your cooling output, balancing loads, and preventing small problems from turning into downtime. Now here's the good part. You can accomplish this with just 3 simple tools: a DL data logger, a PM power meter, and a WISE controller. Now we already made an entire video diving deep into how the DL data loggers work, so if you missed that episode in our data center solution series, you can click here to watch it now. So for this video, we're going to be focusing on the next big piece of the puzzle, PM power meters. So let's jump right in. At the simplest level, a PM power meter is a device that connects to your electrical circuits and measures how much energy they're consuming in real time. Think of your main electrical panel. It shows you the total energy for the entire facility. A PM power meter goes one step deeper, breaking that down circuit by circuit. That means instead of only seeing the big number, you can see where the energy is actually going, whether it's to your chillers, pumps, fans, lighting, or even specific racks. They work by measuring current and voltage on a circuit. Using current transformers or direct connections, the meter calculates power usage, energy consumption over time, and can even track things like power factor, harmonics, or demand loads. The readings are then stored inside the meter and communicated back to your system either over Modbus TCP or Modbus RTU. In order to be operated, a PM power meter simply needs a power source, a connection to your circuit, and a communication path. Whoa, that was a lot of information, but don't worry, I know it can get confusing, so I'm gonna make it super simple. Figuring out what you need really just boils down to 3 questions. So ask yourself this: what are you measuring? How many circuits are you monitoring? And how do you want the data delivered? Do you only need basic kilowatt and amperage readings? Or do you want advanced analytics like harmonics, power factor, or phase imbalance? Some PM meters are also only designed for a single circuit, so you need to decide if you need to measure an entire panel or just one circuit. And lastly, do you need Modbus RTU, which is better used than a legacy system, or do you need Modbus TCP, which is meant more for modern Ethernet-based systems? So to put it even more simply, if you need basic kilowatt and amperage readings and you own a legacy system, you could use this PM meter along with Modbus RTU. If you need more advanced analytics and you own a modern system, you could use this PM meter along with Modbus TCP. Great, so now we're able to not only catch the environmental issues like temperature, humidity, and airflow with our DL logger, but we also have circuit level visibility, so we know exactly how much energy the chillers, pumps, and fans are consuming. Now lastly, in the next video, we'll be going over how to pull it all together with a WISE controller and finally have complete control and oversight into what's actually going on in your data center. Thank you so much for watching this video. I really do appreciate it. Please don't forget to like if you liked, and make sure you subscribe and click that bell so you don't miss the next part in the series. Now on a side note, if you missed the first or second episode in our data center solution series, we'll have both videos on screen right now. I'll see you in the next one.